For the first problem on the free response, we need to find the equation of a tangent line to a parametric curve. So our parametric curve is given by x equals t e to the 2t and y is equal to e to the t. So, and we have the point, we want it at the point e squared. So what you want to first recognize is that doing this one by changing the parametric to Cartesian would be pretty difficult because you have t and e to the t in the same function. It really wouldn't work out algebraically in your best interest to do that. So instead, we're going to have to use just the t values that we have. So remember that if you want dy dx, in other words, the slope of the tangent line at any given x, if you have it parametrized, you can use instead dy dt over dx dt. That will give you the same value. And that works because dy dt and dx dt we can much more easily get. So, what's dy dt? The derivative of y with respect to t, that's just the derivative of this. And the derivative of e to the t is e to the t. Dx dt, that would be the derivative of this one, and we have to use the product rule. So that would give you e to the 2t plus 2t e to the 2t. So that result is our slope of our tangent line for any given t. So we need to figure it out at this point, e squared e. So before I plug those in, let's do some simplification here. We can factor out e to the 2t on the denominator and get 1 plus 2t. And then e to the t and e to the 2t would cancel out and leave this as just e to the t. So finally we get 1 over e to the t 1 plus 2t. So now we can figure out, now all we need to figure out is what is t, and then we can plug it in and we'll get the slope. From the slope, writing an equation of a tangent line is pretty simple. So we know that our Cartesian point is e squared e. So the y has to be e, the x has to be e squared. You can kind of just see by looking at that for a little bit that that means that t has to equal 1. It's the only way you could get e squared for x and e for y. So now if we plug our t equals 1 into this, we're going to get on the bottom 1 plus 2, 3. Here we're going to get e, so we get, so 1 over 3e is our slope. So remember, this was giving us the slope. We found the t, we plugged it in, we got our slope. So now you have a point, e squared comma e. You have a slope, so we can write an equation. So if you use y equals mx plus b, so our y was e, our slope is 1 over 3e, our x was e squared, and b is what we're trying to figure out. This e cancels with this one. We get e equals e over 3 plus b, so that means that b has to equal 2e over 3. So our final equation is going to be y equals 1 over 3e x plus 2e over 3. So there's a few extra steps you need to do in a parametric one versus, the Calc 1 problems that were just y in terms of x. So recall that finding the derivative requires you to do the derivative dt of both y and x of your parametrized equations. And oftentimes the problem is going to be given to you like this, where you're given a point in Cartesian. So you have to figure out the t before you can do anything else. But from there, it's just a basic, point, slope, find the equation of a tangent line.